Hello and welcome to today's session. Today we are stripping away the guesswork and looking directly into the professional methods for installing proper grounding and lightning protection systems. Before we dive into the dirt, if you want to master solar engineering and safety setups, make sure to hit that subscribe button right now. Part 1 begins with mapping. Never just drive an earth rod anywhere. You must plan your location carefully. Choose a spot at least 3 meters away from building foundations and completely clear of underground water pipes, gas lines, or electric cables. Ideally, stay close to the external wall where your solar equipment sits, ensuring the second rod is spaced exactly 3 to 5 meters from the first. When it comes to getting your 16 to 20 millimeter copper-coated steel rods into the earth, which need to reach depths of up to 10 to 12 meters in dry or sandy regions, you have three main options. Method A is a manual driving using a heavy slide hammer and a special driving cap to protect the rod. It's effective for soft soils but highly labor-intensive. Method B is our top recommendation: mechanical boring. Hiring a small hydraulic auger creates a perfect, straight, vertical path quickly and reliably. Finally, Method C uses a guide pipe and sledgehammer, which helps penetrate harder soils but requires significant physical labor. Once your hole is ready, standard soil won't cut it. The backfill procedure is absolutely critical to lowering system resistance. We use a strategic layering technique. Layer 1 at the deep base uses a specialized bentonite and charcoal mixture to lock in moisture. Layer 2, moving up the midsection, incorporates salt-treated soil to maximize ion conductivity. Finally, the top layer blends native soil with bentonite. Always compact gently as you fill, and water the backfill lightly to settle the mixture perfectly around the rod. At the surface, leave roughly 30 centimeters of the rod exposed. Securely attach your 6 millimeter squared stranded copper cable using heavy-duty, rust-proof stainless steel clamps. Both rods must loop directly back to your central copper main earthing bar. For regions facing intense dry seasons, remember our enhancement secrets. The bentonite method creates a highly conductive paste around the rod, while pouring a dissolved saltwater solution creates an active path of conductive ions to maintain a low-resistance connection. Moving into part 2, let's look at the central hub, the main earthing bar. Think of this as the traffic controller for all fault currents. Your DC side ground from the combiner box requires a robust 16 millimeter squared cable. Your inverter AC ground uses a 6 millimeter cable, and your main lightning down conductor locks in at 16 millimeters. Pro tip for sizing: always ensure your ground cable is at least 1.5 times the size of your positive DC conductor. Route these cables cleanly through protective plastic conduits, and never bury them raw in the dirt where corrosion can destroy your path to safety. Part 3 is your roof shield, the lightning protection system. Your main copper lightning rod must extend 1 to 2 meters above the highest point of your structure, typically requiring an 8 to 12 meter rod for standard solar arrays. Anchor it firmly along the roof ridge with stainless steel brackets spaced every 1 meter. From there, run your heavy conductor cable straight down the exterior wall. It must be as straight as possible. Avoid sharp bends because lightning current will jump right off a sharp turn. Keep it securely isolated away from your indoor AC power wiring. In highly exposed environments or thunderstorm-heavy climates, configuration matters. We recommend multiple air terminals at the roof corners linked to a dual earth rod setup, but structural rods are only half the battle. Part 4 brings protection inside via surge protection devices, or SPDs. You must install a Type 2 DCSPD immediately after your main DC disconnect switch to guard your charge controllers. Concurrently, mount a Type 3 230-volt A CSPD inside your distribution panel right next to your inverter breaker. These devices act as specialized internal circuit walls, absorbing massive voltage spikes in less than a single microsecond. An unverified grounding system is a false sense of security. Part 7 covers ongoing testing. You must test your earth resistance immediately after installation, annually at the end of the dry season, and right after any major lightning strike. Using a digital megometer, ensure your system registers a target threshold of under 4 ohms. If your reading spikes above 5 ohms, it's time for immediate remediation. Tighten your clamps, apply fresh bentonite paste, or re-soak the grounding zone with salt water. Run a quick quarterly visual check on your SPD window indicators. If the status light has tripped, the device has sacrificed itself to save your system and needs immediate replacement. By avoiding common traps, like using cheap aluminum wires or skipping surge devices, a pristine grounding framework ensures complete protection for your premium solar panels, inverter units, battery banks, and most importantly, your family. If you found this technical walkthrough helpful, hit that like button, drop your installation questions in the comments below, and subscribe to our channel for more definitive engineering guides. Thank you for watching and stay safe.